Imagine a single function behaving differently based on the context it's used in. That's the magic of polymorphism. Polymorphism is like having multiple disguises for a single character. So what makes polymorphism so valuable? Well, it fosters code flexibility. We can write functions that can work with various types of objects, enhancing the code reusability. There are three main methods included in polymorphism. Number 1. Method overriding. We have already seen method overriding in our previous tutorials. When there are two methods with the same name, the recent method overrides the existing method and gets executed. It is known as method overriding. Let's head to the screen and see how we can implement method overriding. So as you can see on the screen, I have the car class as the parent class and the Audi and BMW as the child class. So I will create an object BMW, pass my brand BMW and M5, and if I run it, I can say it prints this is the car class, which means it has initialized the init method of car class. But as we know, our Audi class has its own init method. So I will write obj1 is equal to Audi, pass Audi, R8. So it will print this is Audi class, which means it has overridden the init function of the parent class. So this is how method overriding works. It not only works on the constructors, but works on any methods of the same name. So next is method overloading. So when we create methods with the same name but different numbers of parameters to work according to our given input, it is known as method overloading. Let's see if we can do it with Python. So here I will create a class named math, and inside this I am defining a method named area with parameters as self and r, and it will return 3.14 into r raised to 2, which is nothing but the area of a circle. And I will create another method named area, which will take in inputs as self, length and breadth, and it will return length into breadth, which is the area of a rectangle. So now we have created the class. I will create an object. So I will write obj is equal to math and create an object of the math class. And if I write obj.area and pass phi as r, it throws me an error by saying missing one required positional argument breadth, which means it has triggered the second area method that we have created. And because of that, we have to pass two parameters, which is length and breadth. So this is known as method overloading, and unfortunately we cannot achieve it using Python. Lastly, we have operator overloading. Operator overloading is achieved when an operator performs differently on different data types. Let's see how we can perform it. So let's see what happens if I add two strings. I will write hey plus there. Now you can see I got a concatenation of two strings. It says hey there. Now let's try to add two integers, 5 plus 8. Now it is giving me an addition of both of these integers, that is 13. Let's add two lists. If I run it, I can see the mergings of these two lists. So as you can see here, there is a common operator that we have used on all these data types, but it performs differently on different data types. And that is what is known as operator overloading. So now we are well versed with polymorphism and its method in OOP. If you haven't watched the previous videos on OOP, here they are on your screen. Make sure you don't miss any of it. Till then, keep learning and thanks for watching.